So let's find all the zeros of the function below, and then we'll write it in factored form. Afterwards, we'll sketch the graph. So g of x has degree 4, and because of that, we know that there should be 4 zeros. Now, if we examine the sign changes, the first term is positive, second term is positive, negative, negative, negative. So from first to the second, no change. Second to the third, that's one change. Change from positive to negative. So we'll say, okay, the sign changed here. Then negative to negative did not change, and negative to negative did not change again. So there's only one one sign change. What does that tell us? It tells us that of the 4 zeros, one of them is positive, and therefore 3 should be negative. All right, so now we know that we have 4 zeros. We know what kind of zeros we have. We have one positive and 3 negatives. Okay. So the next step would be to list the possible zeros. So we're going to generate here our list of possible rational zeros. And what we observed is that okay. What we observe is that the constant term and the leading coefficient will help us determine these numbers. So we are going to include positive and negative of those numbers that we are going to generate. So how do we generate these numbers? We take the constant term, which is 12. We find the factors of 12, which are 1, 2, 3, 4, 6, and 12. And then we take the constant term. The constant term is right here. If we don't see it, it's understood to be 1. So that's a leading coefficient. This is the constant term, and this is the leading coefficient. So the leading coefficient is 1, and the factors of 1 will only be 1. So now we are going to divide the factors of 12 by the factors of 1. And so we'll just have 1 divided by 1 is 1. So we'll list that. 2 divided by 2 is, no, 2 divided by 1 is 2. 3 divided by 1 is 3. And so our list will just be like this: 3, 4, 6, 12. Okay, so this tells us that the 4 zeros that we're looking for, we might find all of them in this set. So that means we're not going to attempt to show that whether 5 is a zero of g of x or not, because 5 does not belong to the list. Okay, so now we're going to start looking for those zeros. So what we want to do is plug in 1 into x and see if g of x will turn out to be 0. If g of x turns out to be 0, then 1 is a 0 of g of x. If g of x doesn't turn out to be 0, then 1 is not a 0 of g of x. All right, so we're going to use synthetic division to find all the zeros. So, and to do that, we will take the coefficients of the terms in g of x. So the coefficient here is 1, and we'll take that. Then here, 4, we'll take the 4. We'll take the negative 1 from here, and we'll take negative 16 and negative 12, and then list them down here. So we'll have 1, 4, negative 1, negative 16, and negative 12. So now we'll try and see if 1 is a 0 of g of x. So we'll take 1 from our list and put it here. And then now I'll have 1, bring it down here, and then multiply by 1, we get 1. 4 plus 1 gives us 5. 5 times 1 is 5. Negative 1 plus 5 is 4. 4 times 1 is 4. Negative 16 plus 4 is negative 12. Negative 12 times 1 is negative 12. And therefore, we will not get a 0 because negative 12 minus 12 is negative 24. So this tells us that 1 is not a 0 of g of x, but it tells us that g of 1 equals negative 24. Okay, so 1 doesn't work. We're going to try now the negative of 1. So let's try negative of 1. So make this negative. So again, we bring down 1. 1 times negative 1 is negative 1. 4 plus negative 1 is 3. 3 times negative 1 is negative 3. Negative 1 minus 3 is negative 4. Negative 4 times negative 1 is positive 4. Negative 16 plus 4 is negative 12. Negative 12 times negative 1 is positive 12. And we will get here 0 because we have here opposites of each other. When we add opposites, we get 0. What does this tell us? This tells us that negative 1 is a 0 of g of x. So negative 1 is a 0 of g of x, and therefore we can write, I'll start here. Okay, so we can write now g of x as, okay, we found 1, 0. Therefore, the factor is, so if negative 1 is a 0, the factor is x plus 1 or x minus negative 1. So let's just do it like that. X minus negative 1, which will turn to x plus 1. All right, so now we have 3 more zeros to look for. So let's try now 2. So if I put 2 here, is it going to work? So let's find out. So we bring down the 1. 1 times 2 is 2. 3 plus 2 is 5. 5 times 2 is 10. Negative 4 plus 10 is 6. And 6 times 2 is negative 12. Now we found another 0. Oh, this is positive 12. And therefore this is 0. Okay, so notice that our number here, the result gets shorter. So we started off with this. Then after we found a 0, then we have just this 1, 2, 3, 4. And then now we just have 1, 2, 3, and then 0 in the end. Okay, so we found another 0. That means to say that we can write another factor for f of x, for g of x, which is if 2 is a 0, then the factor is x minus 2. All right, so now let's look at or look for the next zero. So 2 worked. So maybe let's try negative 2. Maybe negative 2 will work. Okay, so we bring down 1. 1 times negative 2 is negative 2. 5 plus negative 2 is 3. 3 times negative 2 is negative 6. Oh, and we found another 0. So negative 2 is a 0 of g of x. Therefore, we can write another factor of g of x, which is x minus negative 2. X minus negative 2. So now we just need to find one more 0 because we already have 3 zeros here. We have our 2 negative zeros, 1 positive. So the next 0 that we're going to look for is a negative number. But we could just use this. This is the last factor of g of x. See, we have 1, 2, 3 factors already. The last factor is here, and it's going to be 1x plus 3. All right, so that's the last factor, x plus 3. And to solve for the 0, we just set this equal to 0, and then we solve for x. So we now take away 3 from both sides. And so we'll have x equals negative 3. There, we have found all 4 zeros. 1, 2, 3 of them are negatives, and we have 1 positive. And they all belong in this list.